Here is a second example. Given two vectors of magnitude 5 and 10, what could be the maximum and minimum magnitude if we sum them up together? Well, that's all we got from the question. What are we going to do? So let's just draw the two vectors, right? So we have vector A, which has a magnitude of 5, and we say that vector B has a magnitude of 10. What we don't know is how they make an angle with respect to each other, but let's call it theta anyway. But we don't know what theta is. So if we sum them up, we know that the resultant vectors will have a magnitude according to this formula, right? We are given that A is 5, B is 10. What we don't know is cosine theta, or the theta. But what we know because of cosine theta is that the value of cosine theta falls between -1 and 1. When is theta gives cosine theta a value of 1? The answer is when theta is equal to 0 degrees. On the other hand, when theta is equal to 180 degrees, you have a cosine theta of -1. So what's changing in this situation is theta, right? We have a fixed value of a square, fixed value of b square. You're varying this. So if cosine theta is positive, this whole term will add up to these constant. So c is going to be increased. So therefore, this case is a maximum magnitude. On the other hand, if the cosine theta is negative, like -1, this factor is going to decrease whatever inside the square root and therefore lower the value of magnitude c. So when it's -1, that's the worst negative ever. So we are having a minimum situation right here. Let's consider the minimum case first. In the minimum case, theta is equal to 180 degrees. What it means is that this angle, if I draw from the head of A to the head of B like this angle is going to be 180 degrees. This is what is happening here. So I'm drawing from the head side of A to the head side of B, and this is my angle, 180. What you're seeing here is that A is pointing that way, B is pointing the other direction. So A and B are in the opposite direction to make an 180 degrees. Now we are going to add A and B together. The way I set it up is that I am attaching the tails of B to the head of A. So A is the first to sum, B is the second to sum. In order to draw that, I have to draw from the tails of A to the head of B to make a vector C. So C is like this. You can see that C is short, right? What's the magnitude? Well, you can plug it into the equation. This equation, pretty much. So C is equal to square root of 25 plus 100 minus 2 times A, which is 5, B, which is 10, and cosine theta, which is -1. Sorry, it has to be a plus. But because you have a -1 over here, the whole terms becomes a minus. So you have a minus 100 here, and this guy cancel, and you have C is equal to 5 right here. Interestingly, you can think of it this way. You start with A, you walk in this direction 5 units, and you walk back 10 units. So there is some cancellation of the distance you walk. So C can be as simple as 10 minus 5. The magnitude of C is 10 minus 5, which is equal to 5, because there's some cancelling effect in the magnitude. On the maximum case side, you have theta is equal to 0 degrees, what is happening is that this angle, if you draw from A to B, is closing. So you're bringing the head of B closer to the head of A. So essentially, you don't have any angle at all. They are aligned like this. So what I'm drawing here is A and B over here. They are parallel, pointing to the same direction, because we are closing the angle between A and B when theta is equal to 0. I stack them up, putting the tails of B to the head of A. So A is the first, B is the second. I have to draw from tail to head, and that will make a vector C, and C is super long, as you can see. What's the magnitude of C? We can use this equation again. So C is equal to square root of A squared plus B squared plus 2AB cosine theta, and cosine theta is 1 in this case. So you're adding 100 to whatever comes ahead. So in total, it will be square root of 225, and therefore C is 15. You can think of it this way as well. You start with A, you walk 5 units, and then you continue because B is pointing to the same direction as A. You continue for another 10 units. So C can be just A plus B, which is 5 plus 10, which is 15. You can add the magnitude in this case or subtract the magnitude in this case only when vector A and B are parallel. And parallel means two things. First, it can be in the same direction, like this case, or it can be in the opposite direction, like that case. If they are in the same direction, you can add the magnitudes. If they are in the opposite direction, you can subtract the magnitudes. To enforce your learning, write, comment, or share what you have learned today and hashtag PhysicsLitUp. And subscribe to Physics Lit Up for the next video.